All right, so for question number 2, this is from the practice exam. It says, suppose the frictional force between a 1700 car's tires and the ground is 1500 newtons. How fast could the car go around a circular curve with a radius of 98 meters without skidding? So in this case, the friction provides the centripetal force for the car to round the curve. We can find the tangential velocity. So that's it's saying how fast. So the first thing we need to do is find the tangential velocity. So remember that the force, the centripetal force, is the mass of the object times the velocity of the object squared. This is tangential velocity. And so let me just kind of review, just in case you guys don't remember. There's a lot of stuff we're talking about. So this is, oops, let me move this up here. So you got this car over here. That's the sound it makes. Perfectly drawn car. And it is flying around this circle. Now, it's going to have a centripetal acceleration, which is associated with a centripetal force going towards the center of the circle. But I need to figure out what the actual velocity would be. Now, they give us a little bit of a clue, so we're going to start with this. This is the centripetal force going into the center of the circle. That's what keeps it on the path. So what I want to do is I want to solve for velocity. So to do that, I'm going to multiply both sides by r squared. Okay. And when I do that, I get r times f is equal to the mass times the velocity squared, and then I divide by the mass. The masses cancel, and if I take the square root of the radius times the force over the mass, that gives me the tangential speed or velocity, right? So that's what I'm trying to figure out, is the tangential velocity. And that's really all I need. Now, some of this information is, remember that the frictional force is what holds it in its circular path. So when they say, suppose the frictional force between the car and the ground, that's what's holding it in its circular path. Well, that's a force. Okay? So our radius then was 98 meters, right? Our centripetal force was 1,500 meters. Uh-oh, it's already starting to screw up. And then, what's the other thing I need? The mass of the car, right? Which was what, 1,700 kilograms? So I have everything I need. So I'm just going to plug that in. I'm going to say 98 times 1,500 all over the mass of the car, which is 1,700 kilograms. And then I got to take the square root of that to get the velocity. Oops, dang it. The tangential velocity, which is about 9.3 meters per second. Okay? And I'm not sure if you guys, I say it and you guys are just kind of quietly doing your own thing. Remember, for this car to stay on the circular path, it wants to go in a straight line. So this is my tangential velocity. Well, what keeps it on the circular path is there is an acceleration. That acceleration goes towards the center of the circle. at a constant rate, which keeps it on the circular path. Well, if you take the mass times that acceleration, that's where you get this force. Now, the frictional force opposes it, right? So, in other words, you have a force that's pulling it in, and the frictional force is equal and opposite. That's what keeps it on the path. I don't know if that registers. Think about it later, but that's what it is. So then our force is 1,500 newtons. That's the only trick to this one for the most part, okay? And then you'd have to go into your, and this is centripetal, so F of C for centripetal force, that's really a C. My whiteboard thing has been giving me a hard time. Okay? Any questions on that one? Yes. Yeah, I'll leave that up there